In this video, I'm going to show you how to remove last node in a singly linked list. Here I have my pseudocode. What you see here on the first two lines, this is dealing with our edge cases. We are going to have a couple of them that I do want to handle. And the first one is seeing if the length is 0. So in that case, over here, let's go ahead and set up our method, and I'm going to call it pop, which doesn't take any arguments. All right, so the first edge case is checking if this dot length is equivalent to 0, then just return undefined. All right, so immediately we'll want to just stop executing this method, because really there's no reason for us to remove any nodes if none exists. So the second edge case that we have here is to check if the length is 1. If this dot length is equivalent to 1, then I want to do a few things here. The first thing is I want to reset the head and the node, or the head and the tail, to be back to null. And I want to decrement our value, and as well as exit this method altogether. So first thing is we're going to reset the head to be equal back to null, and set this dot tail to be null. And as I said, we're going to decrement because we are still keeping track of the length of our singly linked list. And since we're going to be removing a node here, this dot length minus minus, and then finally we want to return. I want to return this. You could also just return and just immediately just exit the method, but I actually want to do return this. All right, so we have taken care of our edge cases. So now let's go ahead and proceed. So the next thing we want to do is we want to set current node and set previous node. These are two variables we want to keep track of throughout our execution here. So the first one is the current node, and set this one to this dot head initially. And the next one is for the previous node, and set that initially to nil. Next, we want to start a loop. So loop while current node has a next property. So while current node dot next, then move within this code. Within this block of code here, when first make the previous node to be the current node, and we're going to make the current node to be the current node's next property. All right, so at this point, we're going to do previous node dot. The previous node is going to now be equal to the current node, and the current node will now be the current node dot next. And this is all we need, just these two lines here within our while loop. Okay, now so what this loop is essentially doing is we are looping through our current node, which starts off at the head, at the very beginning of our list. And we are looping so long as the current node has a next property. And if that's the case, then we proceed inside this code, and we are continuously going to reassign the current node and previous node. So to start off with, we'll end up changing the previous node value to be the current node, and changing the current node value to now be the current node next, because it's like we are, each time we run through the loop, we are advancing or advancing these 2 pointers, the previous node and the current node, to move forward. If you can imagine, the pointer is moving 1 step forward in this list, one by one. And the while loop would eventually stop once we have reached the end, because this while loop, as you can see, current node.next, well, if the very last node, then the very last node's next property would be considered null. So in that case, this would stop. It would pretty much stop the looping and proceed to run the code after whatever runs after the while loop. All right, so at that point, once we exit the while loop, then we know at that point that what we have currently in the current node as the current node will be considered the very last node of the list, and the previous node would be the second to last of node to the list. And the reason why it's important to have that previous keep track of also the previous node is because remember that once we remove that current node, which eventually is going to be the last node, we want to make that previous node to the previous node to it to be the new last node, or the new tail. So for that reason, we're keeping track of these 2 variables here, okay? Because the previous node, as I said, it will be considered, it will take over as the new tail. All right, so here, as we exit the while loop, we're going to make the previous node's next property to equal to null. It's going to make a previous node dot next equal to null, because again, remember what I said, that the previous node will be the new tail, and because it's going to be the tail, or the last node inside this list, we need to make its next property equal to null, right? Because it won't point it to anything. It will be the last node. And then next, we want to make the tail to be the previous node. Like I said, the previous node will be considered the new tail. So we're going to do this dot tail to be the previous node. So just by doing this, by making the tail the previous node, then now we're ready. Then that means that now that the previous node, since here the line before we set the next property to null, so here now that it's a tail, then automatically there's nothing pointing to what was considered the current node, which at the time was the tail. Okay, so now we have made the new tail to be the previous node. And then finally, we want to decrement the value and return this. So now we're gonna do this dot length minus and return this. And this should be it. That should be it right here. All right, so right now, as you can see, we instantiated our single linked list, and we are pushing a total of 3 values. So we should have 3 nodes that exist for our single linked list. We have the 7, the 14, and the 19. So let me go ahead and expand this here. Yeah, okay. All right, there we go. And I am going to run this code. And as you can see currently here, you see we have a length of 3, with the head being the 7 because it was the first value node that we pushed in, and then as a tail we have 19, which as you can see is the last value we pushed in. All right, so now what we want to do is let's go ahead and use our pop method. So I'm going to do list.pop. So in this case, what do you think will happen? Well, remember, the purpose of this is to remove the last node. So if everything goes well, then when we push this 19 should be the last one, the one that would be removed. So if I go ahead, I'm going to clear this up here and run the code again. And then now look at the length. We have 2. So far so good. and you can see that the tail no longer is that 19. All right, now it's the 14th. So all we have currently in our linked list is the 7 and the 14th. 14 because the last one, which was the 19, was removed. All right, good. So let's go ahead and do it again. I'm going to paste another pop method. So what do you think will happen now? Well, if everything goes well, then we know that we're going to remove we're going to have 19 and 14 removed and end up with only one node inside our list, which is a 7. So let's go ahead and check that out. Delete that, run our code, and you see we have a length of 1, and as the head we got 7. Okay, 7, and the tail is also 7 because, again, you know, if we only have one element, it's going to be considered the head and the tail, right? All right, so that's good. All right, let's do another one here. Let's dot pop, and then we know that in this case, well, this should remove all of our nodes in our list, and we should end up with a length of 0 and have nothing inside our list. So if I run this code here, length of 0, and you can see that the head is null and the tail is null. All right, and the reason for that is because we ended up running this block of code here when we were at that when we only had one existing node, and we did this pop method on it. It ended up executing this block of code here, which was for the second edge case to check if the length is 1. In that case, it reset both the head and the tail back to null, decremented that value, which gave us a 0, and we returned this. All right. So if we didn't do this return this, by the way, if we just like ended up just doing return, then it wouldn't return this this object here, giving us the head of null, tail of null, and the length of 0. For that reason, I kind of still wanted to do it so I can still see these property values. All right. So return this. All right, another thing I want to tell you guys is it's important that you have this edge case here, because sometimes where we're checking if this dot length is 1. The reason being is because you might come across thinking that simply just having this edge case here of the length of 0, it's good enough. That's all you need. But if we were to remove this here, I'm going to comment this out right now. The length of 0, the length of 1. And again, as you saw here, it should, since we have 3 pop methods and we inserted a total, we pushed in a total 3, we should end up with just like this, as you see in the bottom in the console, the head null, tail null, length of 0. But as you will see right now, and I'm going to show you by commenting this edge case here of length of 1, watch what happens. I'm going to run the code, and you might see this error here. Type error, cannot set property next of null. All right, which is this is where we're getting that error. All right, because the reason being is because without this here, what ends up happening is that this method will start running. So if we look at the very beginning of the execution of this method, it will start to check is the length 0. No, initially it won't, because we'll have at least one, okay, at least one node. And then here, when we're initially setting up our current node and previous node, you can see we have this dot head to start off with and the previous node to null. And then from the very get-go, when you start running this loop, this while loop, it's going to check if the current node has a next property. Well, again, because at the moment, if we were to run this code here, which only at the moment has one node, then that means it wouldn't have that one node's next property would be null, right? Because it wouldn't have the next property would have nothing. It would not point to anything because it's the only node. So in that case, this loop wouldn't even run. Instead, it would just skip over it and start running to here and arrive to this line here, which would try to perform a previous node dot next equals to null. But the thing is that the previous node initially it's set to null. There's no next property attached to it. There's no value of there's no next property attached to this previous node. It's null. So for that reason, you see this error here that it says cannot set property next of null. All right. That might be a little confusing, and but I hope that you were able to understand what I mean by that. But just know that if you have this edge case here moved missing, you will run into the error once you arrive to just one at the very last element that you want to remove. Okay, that's just a side note. And aside from that, as you saw, I uncommented this edge case here. So if I rerun the code, that error should be gone. And as you can see here, we go back to what we previously saw, which the test passes. And that is it, guys. So we set up our pop method, and now we have a functioning pop method for our singly linked list.